We've already covered these two questions in class, the third one, fourth one, and let's try this. The question says leave unshaded the required region. Leave unshaded the required region. So when I'm looking at this first line, let this be x is equals to 0, and it says x is greater than 0. So if x is greater than 0, that is right side, so this side is discarded. Second line, y is greater than negative mx plus c, whatever the gradient is, it is just in generic form. So when it is greater than this means it is talking about the upper side of the line, so lower side will be discarded. Two equations done. The third one, this line, so it is greater than 0. Y is greater than mx minus c, so greater than means it is talking about the upper side, so we discard the lower side. Last line, y is greater than 0, so it is talking about the upper side again, so we discard the lower side, and this is our region defined by these four inequalities. Next figure, x is greater than 0 is the right side, we discard the left side. X is less than any particular number, that means left is the region, so we discard the right side. This line at an angle, y is greater than this, greater is the upper side, so we discard the lower side. Then y is less than this sloping side, this sloping line, and y is less than that, so the lower side is the region, so we discard the upper side. Last line is y is greater than equal to 0, this one, y is greater than equal to 0, that supports the upper part, so we discard the lower part. So we are just left with this region, that is 1, 2, 3, 4 and 5 boundaries. This is region R, defined by these given inequalities. Graphs of linear inequalities form the inequalities of the region R bounded by the lines. Equation of each line is given. I can see R right there, and R has 3 boundaries, so I need to explain or give 3 inequalities, which equations are already given. When we are looking at this line in blue, this line is x is equals to 3 and region is to right of it, so the inequality will be x is greater than equal to 3, because greater than is the sign which will take you towards right hand side. Then this line with the positive slope and negative y-intercept, which is y is equals to x minus 2, region R is actually on the upper side of this line, so y is greater than equal to x minus 2. The third line in green, that is negative gradient and positive y-intercept, so y is equals to minus 2x plus 6. The region R actually lies below this line, so that's less than equal to minus 2x plus 6. So these are the 3 inequalities which would define the given region. Now see region R and these solid lines. Region R is actually bounded by these 3 boundaries. So we're going to define them. The first line, let's say this one in green. Now region R is to left of this line. There's a misprint, let me complete that. That is x is equals to 2, and let's say this is that line. So region R is to left of this, so x is less than equal to 2. This line, whatever the equation is, region R is below that, so y is less than equal to minus 2x plus 6. And the third boundary, which is y is equals to 0, clearly region R lies above that line, so y is greater than and equal to 0. past paper question. The diagram below shows the line y is equals to 2y is equals to 4 minus 3x, which is already drawn, and it says on this diagram draw the line y is equals to 1 by 2x minus 2. So 1 by 2x minus 2, there are two ways. As we've already covered coordinate geometry, I can see that the gradient is half and y-intercept is minus 2. So at minus 2, gradient half means rise is 1 and run is 2. Rise 1 and run 2. So if I just follow this, these are 2 steps in run and 1 step in rise. So I know this is going to be the slope. That is one way. That depends on your practice and concept and understanding. I'm going through the same line with a different method. If it is y is equals to 1 by 2x minus 2. Now you can punch in some values of your choice. Let's say I select x is equals to 0. So this is 1 by 2 into 0 minus 2. That's 0 minus 2. That's minus 2. So I'm getting x0 and y minus 2. So x0, y minus 2 is this point in blue. The second choice, let that be 4. So 1 by 2 into 4 minus 2. This is 2, 2, 2 minus 2 is 0. So at x4, y is 0. This is the second point. Now you may use your ruler and pencil only to draw this line. So these are two different approaches. You may use any. Line done. Let me write it so we don't have to scroll up and down back again and again. Now it says shade and label the region are defined by the following inequalities. These are 3. 2 are already drawn. The third one is x is equals to 0. X is equals to 0 is the y-axis. So x is equal to 0 is y-axis. Let me change that. And the inequality says x is greater than equal to 0. For now, I'm just marking a little shade that it is to right of this line. The second equation, which was already drawn by the examiner, it says 2y is less than equal to 4 minus 3x. Whenever we have y and x, you only focus on y. And the equation says y is less than that. So if y is less than that, the region is below this line. So I'm marking this for myself. Third one says, which we just drew, is y is greater than, so it lies above that line. Now I'm looking at these 3, 1, 2 and 3 markings, and I'm seeing that where is the mutual region it satisfied. It is below this line, to right of this and on top of that. So this is the triangle which is satisfied by all these 3 inequalities. Line L is drawn on the grid in the answer space. Write down the equation of line L on the grid. Equation of line L. I can see the rise is 3, the run is 1.5, or just ignore that. Let's find 2 good points because I'm not very certain if it is in the middle or 0.6 or something. So let's say one of the point is this, the other point is this. So this is rise 2 and run 1. So that's a rise over run is gradient, y is equals to mx plus c. Rise over run is gradient, x stays there, and it is intersecting at 3. So it is y is equals to 2x plus 3. Y is equals to 2x plus 3. Now for those who need a different method, you can just choose any 2 points, let them be the same. This is x2 and y7. The other point was this. I'm just selecting a different one. Let's say we select minus 2 and minus 1. So y2 minus y1 is 7 minus minus 1 over x2 minus x1. That's 8 by 4. Gradient is again 2. So y is equals to mx plus c. Y is equals to 2x plus c. Now by this time you should be able to understand that y-intercept is where it crosses the y-axis, which is pretty much obvious that it is 3. But still, if you face any kind of problem, you may substitute any values. I'm using 2, 7. So when y is 7, x is 2, you can simplify and you will still end up with same answers, that's 3. So gradient is already 2, y-intercept is 3, so y is equals to mx plus c is the equation of the given line. B part says on the grid draw and label line x is equals to 1. X is equals to 1 is a vertical line where all this is constant. Let me remove that. So this is x is equals to 1. Second line is labeling it for myself. This is y is equals to 3 and that should be a horizontal line. Y is equal to 3 is this line, and then it says x plus y is equals to 2. I'm rearranging it for better understanding. Y is equals to minus x plus 2. I can see the gradient is minus 1 and y-intercept is 2. Now again, that depends on your practice and understanding. I can see the y-intercept is already 2. This is my point and gradient is negative 1, so rise over run. This is my second point and the line would pass through these. Once you get 2 points, you can just place your ruler and draw the line. And other method is just algebraic understanding. The equation was x plus y is equals to 2. Always suppose the first value, let's say x is 0. So if I suppose x 0, so 0 plus y is equals to 2, y is equals to 2. That is my first set. So x 0, y 2, this is x 0, this is y 2. First point. Second point, any other value. X plus y is equal to 2. Let's say I'm selecting x as 3. 3y is equals to 2, y is equals to 2 minus 3, y is equals to minus 1. So when x was 3, y was minus 1. This is the second point. This is x3, this is y minus 1, second point. So you now join these two blue points with a ruler, you'll end up with the same line. B part said draw these 3 lines, done. Now it says shade the region which satisfies. Be very careful with the wordings. Sometimes it says leave unshaded. Now this time is saying shade the region which satisfies. So it says x is greater than 1. This is x is equal to 1, greater than 1 is to right side. So small markings and we'll decide at the end. Then y is less than equal to 3. This line is already y is equals to something. Less than 3 is the line, is the region below this line. Second done. Now third one. Again x and y. You totally ignore x and just look at y. Y is greater than something. That means it is above this line. Now I'm looking at these 3 markings 1, 2 and 3. So it is above this brown line and it is to right of this red line. Till now above this brown line would have been all this region. I hope you can see the cursor moving. And when it is greater than 1 to right of this line, so we are left with this region only, and the green line says to below, so we are left with this. This is the region defined by all 3 inequalities. Another question. Find the gradient of the line L. 2 approaches again. Any 2 good points. This is 1, this is 2. Rise over run 1 by 2. Gradient is 1 by 2. The other way is I'm selecting these 2 points, not writing the coordinates, directly reading them off the graph. y2, this is 1 point, this is second. So y of this point is 3 minus y of the other point is 2. Over x of the first point is 4, x of the second point is 2. 3 minus 2 is 1, 4 minus 2 is 2. So the gradient is 1 by 2. B part says the shaded region on the diagram is defined by 3 inequalities. We can pretty much see the shape is having 3 boundaries. One of which is already given, that is x plus y is equals to 4. Again, for our understanding, because we've been practicing y equals mx plus c a lot, so rearranging it is y is less than equal to minus x plus 4. Now you can see the y-intercept is 4 and there's only one line which is intersecting at 4. And the gradient is also negative, which confirms that this is the line. So if this is already given, x plus y is less than equal to 4 is already given. So we have to write these two remaining inequalities. So first one is a perfect vertical line which passes through 1. The equation is x is equal to 1. And the shaded region is to right of it, that is greater than 1, leaves me with the choice x is greater than equal to 1 is one of the inequality. Now the second line labeled as 2 or line L, we've already written the gradient and I can see the y-intercept is 1. So y is equals to mx plus c, where gradient is 1 by 2 and c is 1. So this is the equation and the shaded region is on top of it. So y is actually greater, the region is above the line, so y should be greater. So y is greater than equal to 1 by 2x plus 1. So these are the other two inequalities which would satisfy this shaded region. This question is actually a repetition of question 1, but the wording is slightly different. The shaded region on the diagram is represented by three inequalities, one of which is already given again, y equals mx plus c. You can see the y-intercept is -2, so clearly this is -2 and this is the equation, and that's already given. So write down the other two inequalities. One is this slanting line, one is that horizontal line which passes through 3, so equation is y equals to 3. By the time I'm expecting that you would have understood the method rise over run. These are two good points, and there's a rise of 2 and run of 1. So rise over run, gradient is 2 by 1, x is already there, y is equals to 2 by x plus, and it passes through a region, so y-intercept is 0, and the equation is y is equals to, gradient is negative, minus 2x. And the shaded region is above this line, so y is greater than equal to minus 2x. And the other one, the region is below this horizontal line, so y is less than and equal to 3. Sheet complete.